Questions 11 through 20 of the 1998 Grade 7 Gauss Math Contest is what I will cover in this video. Kaylin cut rectangle R from a sheet of paper. A smaller rectangle is then cut from the large rectangle R to produce figure S. In comparing R to S, and then they give us a bunch of answer choices. So let's draw this out a little bit bigger, and what we'll do is we will compare both. So the first one is R, and we've got 8, 8, 6, and 6 on this side. So let's calculate the area and the perimeter because all of these answer choices are talking about area and perimeter. So for R, the area is going to be just length times width, which is 8 times 6, which is 48. And the perimeter is 8 plus 6 plus 8 plus 6. So that looks like 28. All right? So that is the first of our two shapes. The next shape is over here. What they've done here is they've cut a small piece out in that corner. And I will try to replicate what they've done. And that small piece is something that we can figure out because we know that if this is 6 and this is 5, which is what they've given us, then this has to be 1. And similarly, if this is 4 and this is 8, then this is 4. All right? So we can proceed with this, and what I'm going to do is I'm going to draw the cutout portion in a different color. Just to represent that it was indeed a piece that's cut from that shape. So now, like we did with this one, we'll calculate the area and the perimeter. Well, the area of this S is the total area, which is 48, minus the area of the small piece. And the area of the small piece is length times width, which is 4 times 1. So this is going to be 48 minus 4, which is 44. That's the area of S. And this is area of R, this is P of R. This is R, this is S. Now let's calculate the perimeter of S. Well, this is 4. Then we've got 1. Then we've got 4. And then we've got 5. And then 8. And finally 6. So this becomes 28. So now, what's going on? What's the comparison? Well, it looks like the area of R, which is 48, is greater than the area of S, but the perimeter of R is the same as the perimeter of S. So in comparing R to S, it looks like our area will be greater and our perimeters stay the same. So in comparing R to S, well, the perimeter stays the same as only given in choice E. So that's got to be the right. So I assume what they're saying is as you go from R to S, the area decreases from 48 to 44. The wording is a little off. I'd rather say, in comparison, if you're saying like R to S, when you go from R to S, that would probably be better. It'll be less confusing, but that's okay. In any case, even if you just look at the perimeter, there's only one answer that says perimeter is the same, and that's E, so that's the correct answer. Steve plants 10 trees every 3 minutes. If he continues planting at the same rate, how long will it take him to plant 2,500 trees? So we just make a simple comparison. We have 10 trees in 3 minutes. And we want to know for 2,500 trees, how many minutes? So X minutes. X is what we're trying to figure out. Now, we can get rid of the word trees and the word minutes to get 10 over 3 is equal to 2,500 over X. So 10X is equal to 7,500. X is equal to 750 minutes. Now, the answer choices are all in hours, so we have to convert 750 minutes to hours. So since there's 60 minutes in an hour, you would divide 750 by 60, and this looks like it is 12.5 hours. And that would be choice E. The pattern of figures is repeated in the sequence. The 214th figure is. All right, so we've got a triangle, we've got a circle that's been shaded, we've got a square, we've got a triangle that's been shaded, and then we've got a empty circle. And they just keep repeating that. It looks like every fifth one, it just keeps repeating. So if you were to draw this out, I'm not going to draw out obviously 214. We have to look for some sort of pattern. So I'll just draw 2 of these series. So like that. Just like what they gave us. So you notice this is the first, this is the second, this is the fourth, this is the fifth, and so on. 6, 7, 8, 9, 10, like that. So every time we have a multiple of 5, it's going to be this circle, the empty circle. So that means the 15th one, the 20th one, the 25th one, 30th one, and so on. Every multiple of 5. So if you keep going, that's going to go all the way up to 200, 205, 210, and so on. So this will be a empty circle, 210. And then after that, you'll go right back to the same series again for 211, 212, and so on. So this will be 211, this will be 212, this will be 213, this will be 214, and this will be 215. And of course, because 215 is a multiple of 5, we're back to the empty circle. So what are they asking for? 214. So 214 is right here. The shaded or black triangle, which is choice D. A cube has a volume of 125 centimeters cubed. What is the area of one face of the cube? Okay. So here's a cube, and we can label it X, X, and X, right? It's a cube, so all the sides, length times width times height, all are the same. And the volume is 125. So how do you figure out the volume of a cube? Well, it's X times X times X. Or, in a better way, X cubed is 125, which is what they've given us. So if you solve for this, you take the cube root of 125, and that is equal to 5. So X is 5. What they want now is the area of one face of the cube. So for example, this is one face of the cube where they want the area. Well, that's just X squared. So 5 squared would be the answer, which is 25. So that would be choice B. The diagram shows a magic square in which the sums of the numbers in any row, column, or diagonal are equal. What is the value of n? All right, so there's only one column that has all the numbers, so we obviously have to work with that. So we've got 8, 9, and 4. So the sum of 8, 9, and 4 is 21. So that means the sum everywhere of every diagonal, row, column is 21. So I guess where do we go from here? I guess we go here, this row, and we'll call that x. 9 plus x plus 5 is therefore 21. So x has to be 7. So we'll put 7 there. And then how about this diagonal this way? We'll call this y. 8 plus 7 plus y is 21. So therefore y is equal to 6. So as we slowly fill this magic square, everything's starting to come together. And then finally we can now look at this row. 4 plus n plus 6 is 21. So therefore n is equal to 11. So that would be choice E. Each of the digits 3, 5, 6, and 7, and 8 is placed one to a box in the diagram. If the 2-digit number is subtracted from the 3-digit number, what is the smallest difference? Okay, so they've got this 3-digit number, and they will subtract from it a 2-digit number, and they want the smallest possible difference. They want this to be the smallest. Now, the way to approach this question is just look at this. If we want this to be the smallest, we have to start off with the smallest, right? This has to be the smallest possible 3-digit number. And then if this is the largest possible 2-digit number, then that will further help us make the result the smallest. So what's the smallest possible number that we can make with these digits that is a 3-digit number? 3, 5, and 6, I think. I think that would be the smallest. And then for the largest possible 2-digit number, well, we only have 7 and 8 remaining as our digits, so the largest of those would be 87. So that would be our equation, 356 minus 87, and that is equal to 269. So the answer here is A. Claire takes a square piece of paper and folds it in half 4 times without unfolding, making an isosceles right triangle each time. After unfolding the paper to form a square again, the creases on the paper would look like. All right, get out a piece of paper, and make it into a square and start folding. And you're perfectly allowed to do that in a math contest. No one's going to stop you from folding a paper. And I actually did that myself. So when I did it, I got this one right here, C. So this is just one of those conceptual ones. There's no magic formula. Just get a piece of paper and that's in the shape of a square and fold it 4 times, and you will see that the creases look like that. The letters of the word Gauss and the digits in the number 1998 are each cycled separately and then numbered as shown. If this pattern continues, what number will appear in front of Gauss 1998? All right, so what is happening here? What are they doing? All right, 9981. First, I'll write out the first 3, and then we'll try to understand what is it exactly that they are doing in this question. All right, so it seems like they are moving this G to the left 1 unit each time. And similarly, it looks like they are moving this 1 to the left each time. And there's a lot of interpretations. I mean, you might look at it as something different, but that's how I looked at it. So I'll just continue doing that. And hopefully I don't have to do it too long, because let's see, the answer choices are 4, 5, 9, 16, 20. Oh boy. So they want me to go all the way up to 20 for me to eliminate all the possible choices. So, all right, let's do that. So first, to avoid confusion, I'm just going to concentrate on the letters first. So we've got S, G, A, U, S, and then G, A, U, S, S. Okay, whoa, we got Gauss already, but let's see if the number matches. This is going to be 1998, and this will be 9981. Oh, unfortunately, it didn't match, so I got to keep going. Well, the good news is we've eliminated those two, so let's just keep going here. A, U, S, S, G, U, S, S, G, A. Number 8, S, S, G, A, U. I hope you're following. I'm just moving the G. And after a while, you just have to copy what you just did. It's the same thing over again. See, look, the first 5 are the same as the next 5. So you don't even have to think about it anymore. Just copy it. U, S, S, G, A, S, S, G, A, S, G, A, U, S, and then finally we've got this Gauss again. And let's just complete this for the sake of completion. That way we can eliminate all the possible answers. And finally, we're back to Gauss. And then in the same way, the numbers repeat. The numbers are essentially going to repeat, but they're going to repeat every 4 because there's only 4. So this will be 9981, 9819, 8199, and then finally 1998. You see what happened there? These 4 are the same as that 4. So let's just keep going. 9981, 9819, 8199, and then 1998. Same thing. 9981, 9819, 8199, and 1998. They're really making us work hard in this one. 9981, 9819, 8199, and finally 1998. And I forgot the S. So finally on the 20th try we get Gauss 1998. So the answer is E. Juan and Mary play a 2-person game in which the winner gains 2 points and the loser loses 1 point. If Juan won exactly 3 games and Mary had a final score of 5, how many games did they play? All right. First, let's just write down what information they give us. Juan won 3 games. And since there's only 2 players, that means Mary must have lost 3 games. Okay? And then in terms of an equation, we've got wins give you 2 points. So you multiply the number of wins by 2. And then losses, you have to multiply by -1 because they're taking away a point. So this equation gives you your total points. And they told you that Mary had a final score of 5 points. So let's see if this helps us. Well, Mary had 3 losses. So the L here is 3, and this is just 2W, and this is 5. So we've got 2W minus 3 is 5. So 2W is equal to 8, and therefore W is equal to 4. So Mary had 4 wins. So she had 3 losses, and she had 4 wins. So that means she played a total of 7 games, 3 plus 4. And Juan also played 7 games because there's only 2 people, and they play each other. So that would be 19 is A. Each of the 12 edges of a cube is colored either green or red. Every face of the cube has at least 1 red edge. What is the smallest number of red edges? All right, let's first draw a cube. All right, so here is our cube, and each edge, so this is an edge right here, okay? Edge is also one of the members of the rock group U2. But that has nothing to do with the question. So when we have an edge, what do we have to do here? We have to ensure that every face participates in that edge. So for example, if you're going to color, let's say, this edge red, that means that the faces have to include it. So the top face includes it now. And then also this side here, I'll draw a different color. This side here also includes this red. So you see what the question is asking. They're saying, what is the smallest number of red edges so that every face has at least 1 red edge? And after a lot of trial and error, these kinds of questions become a bit more clear. The way to do this is you paint that one red, then you paint this one red, and then you paint this one red. And you will see, with just those 3, every face will have a red edge. So let's see if that is true. The top face, which is right here, does it have a red edge? Yes, it does. The bottom, does it have a red edge? Yes. Now what about this one on the side? Yep, it certainly does. How about this one? It also does. And then the last 2 faces, this one back here, yes, the bottom will be a red edge. And then finally, this one on the side, that also has a red edge at the very top. So 3 is the smallest number of red edges that we need so that every face of the cube has at least 1 red edge. So the answer for this would be B, 3 red edges.